So today we'll be taking a look at these problems here. Okay. Now, basically what we're doing is, remember when we factored, we didn't have an a value sitting on front of our x squared term. So this time we're actually looking at how we handle factorization with that. So our first problem is going to be this binomials part 1. Okay. Now, what we're going to do is we're literally going to look at the ax squared. Now, what we're going to do every time we do this problem is we're going to pull off the ax, not just the x like what we did before. This time we're going to pull off the ax. So here's what we're going to do. Let's take a look at this first problem here. And we're going to zoom right in and make sure we understand what the heck is going on. So this one asks us to factor each binomial, right? Now, the thing that we're going to pull off is we're going to pull off 4. We're going to pull off 4 because 4 can divide both 8 and x. So we're going to pull off that first. Then we're going to look at pulling out an x from both of these just like before. Now you got to ask yourself what's left over. Okay? So what's left over? So what we want to do is we want to look at the first term here, right? So think of it this way. I've literally got 4x squared and I'm going to divide by 4x, right? So what's left over? Whatever's left over is going to go into the brackets, right? So what is 4 divided by 4? Well, that's just 1, right? If I take away 1x from the other x, I'm left with x again, right? And then I got to think about what's happening with the last bit of our problem set, right? So right now, I've already dealt with my 4x squared. So imagine I'm looking at the 8x. I'm going to imagine I'm dividing 8x, and I'm going to put the result into my chart. Okay? So what is 8 divided by 2? 8 divided by 4 gives us 2. X divided by x gives us nothing, so that is our final answer. 1x plus 2. And if you're really good and you really know and you really understand, here's what you do. See this part that says 1x? We don't need it because 1 is understood in front of x. So our final answer is 4x, x plus 2. Now, let's consider working on this next problem, okay? So now we have negative 7x squared plus 28x. Now, I told you when we did this, we were always going to pull off ax, right? Okay. Now, since we're pulling off ax, right? Let's do that for this one. So a in our equation is going to be negative 7, and x is the number that we pulled off, is the variable that we pulled off. So here's my question. Exactly what's left over? So in order to come up with the answer, think of this as a trash can. Think of this thing, this bracket, as just what's left over, a trash can. After I pulled off minus 7x, you got to ask yourself what's left over. So let's go and imagine we have divided this by negative 7x, right? So if I divided this by negative 7x, what happens is this cancels with this, so you're left with, yes, you guessed it, a 1, right? And x squared divided by x leaves us 1x left. So that's great, isn't it? But you know that 1x is just x, right? So just think of it that way, right? And then we have to imagine that we are dividing minus 28x by negative 7x. So we've got positive 28x divided by 78. So positive 28 divided by negative 7. So positive divided by a negative gives us a negative, right? And then 28 divided by 7 is just 4, isn't it? So x divided by x, we can cancel that out. There's nothing left. So the final answer is going to be x minus 4. Now, we're done. That's it, right? Now, as you get better with this, you can skip thinking about dividing it. All right, so let's go and do one without showing all of that work, okay? All right, so let's get over to part C here. So for part C, I'm just going to zoom right in here. So we're going to pull off negative 4.9t. So instead of x, we're using t's this time. So all we're going to do is going to pull it off. So we're going to get positive 4.9t. And the question now is, in the trash can is what's left over. So the key is to say, all right, okay. So in order to make our life easy, we say, okay, 4.9 divided by 4.9 is actually just 1, right? Then we're going to pull off a t from this, right? So there's 2 t's. Pull off a t, you're left with 1 t. So now we've got 1 t left over, right? So now that we've done that, right, let's go over to negative 19.6t. All right, so if I'm going to get rid of the minus 19t, here's the rule. If I'm dividing a positive by a negative, I got a negative still going there, don't I? So now, here's what I'm going to do. I'm going to say, all right, negative 19.6 divided by this thing, 4.9, okay? All right, so negative 19.6 divided by 4.9 is, you guessed it, negative 4. So all that's left over is to remove that extra minus 1 because it's not necessary, okay? So we're left with 4.9t times t minus 4 as our final factorization. So now let's go and take a look at this next one here, d. D is very similar to what we did here. So just above, let's take a look at B. So now, this time, pause the video and try this, okay? You did this one before. You did B before. It's exactly the same as D. And if you think about it, there should be a positive number in between in our bracket. Try it out. Pause it and see what you get. And so now, if we are pulling off negative a, so we got to pull that off. So we got negative 1.2. We've pulled it off, right? And you know what? I think what I'll do is I'll fix that. So negative 1.2, right? So I pulled it off, and I'm pulling off an x. So what we have left over here goes in the bracket. So what is going to go in the bracket? So if you think about it, I'm going to divide both sides by negative 1.2x, right? So this cancels with this, so I'm left with a 1, so I'm not going to put anything in front of x. Now, x divided by x is 2 x's, and we pull 1 x off. All we're left with is simply an x. So now, let's get back to work and do the same thing for negative 220.4. So we divide by negative 1.2x, all right, and we get, so for negative 20.4, right, and negative 1.2, a negative divided by a negative is a positive. Perfect. Then what we're going to do is we're going to take a look at 20.4 divided by 2. And 20.4 divided by 2 is 17. And x, getting rid of x, basically just gets rid of x. So we're left with plus 17. And there is our answer. That's all she wrote. And there is our final answer. Negative 1.2x, bracket x plus 17. And we're done. All right, now let's move on to the next concept of the day. This time, I want you to imagine that instead of what we had before, where we had ax squared plus bx, right? We pulled off an ax in that case, right? This time, because there is no x term on our c, the only thing that we can pull off is the letter A that's sitting in front of here. So let's go and take a look at this example where we're factoring every binomial. So in this case, you're going to look at both of these terms, right? The only common thing that they have between them is a division number of 5. So we pull off a 5 from both of these. And imagine I took this divided by 5 and took that divided by 5, right? So 5x squared divided by 5 is going to be x squared. Okay, so that one's done, right? And now we got to think about 125 divided by 5, right? 125 divided by 5 is still going to be negative, and 125 divided by 5 gives us 25. Now, we are not done, because this thing here is a difference of squares. So you remember how to deal with those. So what we're going to do now is we're literally just going to basically continue our calculation. And we're going to break this thing up into something with x and something with x. And our final answer is, well, it's x minus 5 and x plus 5. And we're done. So now that you're starting to understand that, what we're going to do is we're going to go and take a look at the next problem that we have to our right here, right? So we have 5x squared minus 25, but this time we have, for the second one, we have negative 1.5 x squared. So the key idea is to pull off the negative 1.5. So when we do this problem, we're literally just going to pull off minus 1.5. Okay? And we'll just pause that and we'll zoom in and just do that problem. So now we've pulled off 1.5. Now, all that means is we're going to have something left over. So imagine we divide each of these by negative 1.5, right? So for this first part, we have 1.5, negative 1.5, x squared divided by 1.5. So 1.5 divided by 1.5 cancels out, right? And all you're left with is just this x squared. So let's put that in our solution for our bracket. So now we have x squared. Now we have 1.5 dividing negative 1.5 dividing 54. So here's the rule. If I have a negative and a positive number and they're dividing or multiplying, the overall is going to be negative. So all we got to do is punch in 54 divided by 1.5 and put our answer right here. And calculating that makes us have 36. So we have x squared minus 36 in the brackets. Now, we have a problem. Let's take a look. When we have 1.5 x squared minus 36, and we're dividing, and we have this, we're having a same situation that we had here. Okay? So we're going to have to do something that deals with a difference of squares. So let's go and deal with that now. So I just cleaned up the rest of the left side of my equation. So now we're just going to focus on this last bit. Okay? So now we've got minus 1.5 again. We still have our bracket, but we're going to end up with two brackets because this is a difference of squares. So I'm going to have x and x. And then we have to realize in order to get the proper number that goes in our bracket, we have to take the square root of 36, which gives us 6. So that means we have minus 6 and plus 6 for our answer inside our bracket. And we're done. So now let's move on to the next topic. Suppose I have a trinomial with ax squared plus bx plus c. The key is, since not all of them have an x, is that we're going to pull off the a value. All right, so let's go and do one question. And then I'll show you the rest very easily. So now, each of these numbers is divisible by 3. So I'm going to pull off a 3, and I'm left with, 3 divided by 3 means we have x squared left over. 21x divided by 3 means we have positive 7x. And then positive 36 divided by 3 is still positive 12. So now we need two numbers that times to 12. So let's split up 12. And those are all the possibilities for multiplying 12, because if you notice here, we have a quadratic that can be factored. So assume that all of your quadratics will be factored. So we have an x and we have an x as our final bracketed bit for this part here. So now we need to find two numbers that multiply to 12, but then add to 7. And in this case, we see 3 plus 4 equals 7, and 3 times 4 equals 12, which means our answer is x plus 3, x plus 4 in our bracket, and we are done. As soon as you get to this stage, you are done this type of problem. Well, let's try the next one. Okay, so now for this one, we're going to do exactly what we did here. We pulled off the number that was sitting in front of x. So now, ready? Pull off a 2. What are we left with in our bracket? So think of them as being all divided by 2, right? So now you've got x squared plus x minus 12. Now I'm going to write in a 1 here so that I know what I'm doing. All right. So now I have this 2, and I know that I have to factor this thing, right? Now, let's zoom out a bit and use what we had from before to kind of help us. So remember, before when we did this, right, we had 12, right? We had 12, positive 12, right? But you notice that there's a positive and a negative, right? Because negative 12 needs a positive and a negative. So we have to find two numbers that multiply to negative 12 but add to positive 1. In this case, I'm going to use 3 and 4. Now, I'm thinking 3 and 4 works because if I have x and I have my 4 in here and my 3, in order for it to add to 1, that means 4 plus -3 gives us the answer we're looking for. And we're done. Now, that's it. So now let's go to the next one. So now we've got 5. So for this one, we got x squared minus 10x minus 40. So we pull off an x. So we have x squared minus 2x left over, and then minus 8. So now we need two numbers that multiply to. And now we have our tree that breaks up 8. Now, here's the big trick. You see this minus 2x that we have here, right? Because it's minus 2, we know that the bigger number of these two has to be negative. So minus 8 and minus 4 I'm putting in here. So I'm going to check. Is minus 4 plus 2 going to give me this middle number 2, negative 2? And yes, it does. So I will select that as my possible solution. So now my final answer is 5x, and then we put minus 4 in our first bracket, and then we have x and plus 2 in our second bracket. Okay, and we're done. Let's go and take a look at D. Same thing again. All we're going to do is pull off a -7. So we pull off -7, and we're left with, it's like we're dividing each of these by -7, right? So, ready? -7 divided by -7, so you're left with x squared. Now, we have to consider a positive in mind, a positive and negative, right? Positive and negative gives us a negative, and 21 divided by 7, what does that give us? 3. Done. So it's -3, and we're left with an x. And then we have a negative divided by a negative gives us a positive. And we have our final thing here, negative x squared minus 3x plus 2 as our final answer. So now let's come up with a tree for 2. Oh boy, that's easy. Ready? 2 splits into 1 times 2. Hey, that's easy, right? Now, the key is, because I have a positive at the end, here's the rule. Both of them must be negative, right? Because the middle term is negative, because it needs to add negative, right? So, boom, boom. We got to have -1 and -2. We'll add 2, -3, but -1 times -2 gives us +2. So our final answer is going to be -7 x minus 1 x minus 2 as our final answer. And let me just take a moment and clean up our mess here. All right, let's move on to the next problem on the sheet. So now what I'd like you to do is follow the same pattern that we did before. Pull off 1.5 and then divide everything by 1.5 and tell me what the final answer is. And if you can factor. So pause the video and then I'll show you my solution. And we're done. So for this problem, it's asking us to take a look at the surface area of a cylinder with hemispherical ends, right? The term hemisphere means we have a half circle, okay? As you can tell, on the top of the cylinder and the bottom of the cylinder, both are half circles. Make that half spheres. Okay. Now we need to take this expression and we're going to, this represents the surface area, and we're going to factor it. So let's go and focus on that and get it done. So we start with our basic equation, right? And the only thing that is common to all of the terms, this and this, are the following. Ready? 2 pi r, and then we just got to pull out the rest, right? So our rule is to always pull off the front term. That's common to everything. So we got a pi, we got a 2, and we got an r. So let's just pull it off. That's common between all of them. And now, when we pull off pi r h, we are left with this for our first one. So our first term in our bracket is that plus. Now, if we pull off a 2 from there, it's gone. But how about this? If we pull off a 4, right, with the 2, we're left with 2. Okay? We pull off a pi, it's gone. We pull off an r, we're left with r left over, and we're done. So the surface area is equal to this. So now we have to work on the next part. It says, find the surface area of the following container, right? Use the original and the factored form. Let's do that. So take out your calculator and punch R and H into this one, and then take out your calculator and pull and put R and H into this one and see if which one's easier. Right, so imagine that you're taking your time and writing this out. Well, using the original equation, you're literally going to have to sub this in and then sub in 2 times pi times 510 plus all this other stuff. And you already look at it. It's big, it's messy, and it's bulky. As you're substituting in, you got to collect like terms and then add and then multiply. Oh my goodness. And you got to multiply 200 by 3.14 in the end, and you get 628. Now that was a ridiculous calculation to do. And 9 times out of 10, you guys and I would mess that up. Now, in order to do this right, you got to use the proper factored form, right? There's our factored form showing up on our screen here. And this factored form that's in red here is what we're using here. Now, substituting in is really nice. There's a lot less stuff to deal with. There's a lot less pi's, a lot less multiplication. It's really easy multiplication inside here. And I'm going to tell you right away that the factored form of this is way easier to use. Now, here's a question for you. All right. So you notice that the height of the container was double the radius. Okay? Suppose that this is always true for containers of this type. We're going to use this type of information to simplify both expressions for the surface area. So to start, let's go and get those equations and put them down here. Okay, so for the hard problem, we literally just start with our basic equation. And all we're going to do is we're going to sub the height, what it says the height is double the radius. So we say h is equal to 2r. So let's go and substitute in and see what we get. So this equation becomes this. And what's interesting is now we just have to kind of pull all the 2's together in this part. So the 2's, this is multiplication between this bracket. So 2 times 2 gives us an answer of 4. And then there's still a pi, so we'll take care of that. But now we have 2 sets of r's, right? R times r gives us r squared. And then we also have the last bit to add on to our answer. So we got 4 pi r squared. So that means we have what? 8 pi r squared as our final answer for our surface area if we use the original hard equation. So let's go and do the easy equation now. And now let's just make sure we have enough space here. So our answer for the easy one is going to be SA is equal to 2 pi r bracket h plus 2r. All right, so now we're going to do exactly the same thing that we did before, where we sub h is equal to 2r into our equation. So now you're going to get SA is equal to 2 pi r times, well, h is just 2r, isn't it? 2r plus 2r. Isn't that just 4r? So we end up with 2r, 2 pi r times 2, nope, not 2 pi r, times 4r, which means that these two come together to form 8. And then we also have these two. We have a pi here. Then we're going to take our r's and bring them together to get r squared. Holy geez, the surface area is equal to this and this, and it will always work for both. Now there's your homework at the bottom of the page. Good luck. Have a good day.